All right, let me say first of all, welcome back in the summer session 2. And today we're gonna begin our first lecture in DCS 620, which is data visualization and dashboarding, which we're gonna learn so many things about how to visualize data through multiple softwares. So, as a first step, we need to make sure what we're gonna learn throughout the lecture, and here is what's in for you. So first of all, we're going to have like a introduction and then answer the question what's data visualization, and then I'm going to talk a little bit about plots, line charts, bar graphs, histograms, scatter plot, heat maps. Now all these going to be just like introduction. Draw Python using the library matplotlib and also cburn. Pretty sure most of them you learned them before, but it's gonna be like a reminder. Another thing that I have to let you know, you're gonna make sure that you do have Notebook Jupyter on your device. So if you got trouble on that, you just have to let me know. And after that, of course, we're gonna learn new libraries also through the classwork. I am going to teach you more stuff like about the visualization. But for the moment, here is our plan today. Okay. Um, just like as you know, before going to the introduction, wherever I got like instructions, comments, programming, coding, draw Python, you're gonna make sure to do it, okay? Another thing that I have to let you know, wherever there is a data that I'm gonna use, I'm just gonna share it with you, of course, the resources in the platform or in our e-learning, okay? So basically, while working with data, it can be difficult to truly understand your data when it's just in tabular form, like when you got so many rows, so many columns, and then you are working in company, and then you want to make a presentation, draw the products of the company. Now, of course, not everyone can understand what's going on through the database, right? And of course, you have to visualize the data in another way, in an easier way that everyone can understand without going through the coding, without going through, databases, etc. To understand exactly our data conveys and to better clean it and select suitable models for it, we need to visualize it or represent it in a pictorial form, just like pictures. This helps expose patterns, correlation, and trends that cannot be obtained when data in tabular table or CSV file, of course, because like for example, if we do have two variables, so like the time and then the sales, and then we got the data in a CSV like file or spreadsheet or whatever, of course, you cannot see any relationship, okay? Even if you know what does it mean a database or whatever is the data, okay? However, we need to expose and see, of course, the patterns, okay? And and also the trends, the correlation, just like the word that you got on the slide. This is important. How we're gonna do that? We're gonna do that through the visualization. Got it? So the next question, because we understand now that the visualization is important, okay, why it's important, but the question is, let's see, what's data visualization? That's really important. It seems that it's easy, but there is things that we have to understand, that we have to go deeply through. The process of finding trends and correlation in our data by representing it pictorially is called data visualization. Okay. To perform data visualization in Python, we can use various Python data visualization models such as uh, Matplotlib and Seaborn, also Plotly. There's also something called Panel. There's Bouquet. Like each one has its advantages and drawbacks. One of them is old. One of them is has like easier functions to go through, etc. Now, in the first week, I'm gonna focus. Just gonna be like a reminder about Matplotlib and Seaborn. So we're gonna make sure, okay. So it remind you because these functions are also important. Okay, however, in dashboarding, etc., it's going to be Plotly. Also, we're going to learn a little bit about, we're going to go through also Tableau, but it's going to be later by the end of the course. Okay. um all right, so just want to let you know ahead what we're gonna do. Oh, as you can see in the picture, draw the slide, we do have a pie chart, we do have a histogram, we do have a bar chart, and we also have something called the line chart. Okay, now I'm gonna go through each graph. Okay, how you're gonna do it? Of course, plot like in Python, what libraries you're gonna need, and what's the comments or functions that we're gonna need also, or we're gonna use basically. All right. So first one, before going through here, I'm just going to talk a little bit about data visualization, which is an important step, okay, for any data scientist. He needs to make sure to check the trends, the patterns. So data visualization is a field in data analysis that deals with visual representation of data. It graphically plots data and is an effective way to communicate inferences from data. Okay? It says inferences. I want to underline this word because, as you know, when we're going to work on certain problem or domain, we're not going to use the whole data, like the whole population. However, we're going to do that on just like sampling, okay? And draw the trends and patterns of that sampling. It's gonna inference or get us an idea globally about the population. Hopefully that clear. And if you have a question, of course, you can let me know later. Using data visualization, we get a visual summary of our data. We know what's going on, right? With pictures, maps, and graphs, the human mind has an easier time processing and understanding any given data. Now, for us, it's going to take time because we have to clean data, we have to make the presentation. But for other people, once we got the pictures, it's clear. Data visualization plays a significant role in the representation of both smaller and large data sets. Because sometimes we do have small data sets, others wise it can be large. But it is especially useful when large data sets in which it is impossible to see all of our data, let alone process and understand it manually. All right. Okay. So in Python, um, or actually Python offers different plotting libraries, namely Matplotlib, Seaborn, and many other, such as data visualization packages with different features for creating informative, customized, and appealing plots to present data in the most simple and effective way. Okay, just like I let you know, our first lecture we're gonna be focused on Matplotlib and Seaborn, and just a reminder that on the classwork I'm gonna walk you through. We already worked with this library, but I'm gonna show you more comments, more important comments. also in the homework, of course, of currently I forgot the name, but it's the library of like working with the data set CSV files. Okay, pretty sure you know it. Okay, so we do have the bar charts, the pie charts, and the donut charts, the scatter plot, the maps, the heat maps, the valid graphs, and the tables. Okay, let me go through uh, like the difference between Matplotlib and Seaborn. Matplotlib is used to embed graphs into applications. Okay, Seaborn is primarily used for statistical graphs. Okay, and like I told you, we're going to learn also panel and plotly later. Okay, to make dashboarding. Dashboarding in plotly easier than panel. So the only difference, both of them, they work good. It's just like panel is a library older than plotly. Okay, if you are curious about, and there is more libraries, but like the most known in dashboarding is Plotly, and it's also easier to use. So we're gonna learn that, of course, later, after we make sure to check the difference between Matplotlib and Seaborn. So Matplotlib, it's used for basic graphics, just like line chart, bar chart. It mainly works with data sets and arrays. However, Seaborn can perform complex visualization with fewer comments. It works with the entire dataset. Seaborn has more inbuilt terms and is mainly used for statistical analysis. However, Matplotlib is customizable. And pairs well with Pandas. Oh, that's the library that I want to talk. Pandas and NumPy for exploratory data analysis, EDA. Okay, Seaborn is considerably more organized and functional than Matplotlib. However, Matplotlib acts productively with data arrays and frames. Okay. Please remember the difference because you might have questions in the quiz about the difference between Matplotlib and Seaborn, because we're going to have a short quiz next week which is going to have 5 questions. Please remember that. 5 questions throughout the lecture. So make sure you make notes of your lecture. Okay? Now, one of the easiest way to make a visualization is the line chart. So a line chart is a graph that represents information as a series of data points connected with a line or curve. So as you can see, we got the data set. So basically, if you don't wanna already here I did the year, but it's fine. What I want to say here, it just make sure it just there is no the variable year, it's not there, but you may add an array that has 2010, 2011, 2012, 2013, 2014, and 2015. That's for the years. Okay, that would be your x values. Your y values, it would be yield of apples, or let's say that I'll make sure also to import the libraries, and then make sure to label your data, X label and Y label. What do we have on the X axis is the year. What do we have on the Y axis is like the yield of apples. Okay. Yeah, it just plot for line chart, nothing special. And of course, we need Matplotlib for that. Okay. and you got your data, so it's going to be easier to do. Okay, just like I said, the only missing parts here is just the years, but you can add another array that for year. Okay, or you can just make like range 2010 to 2015. It would give you the same result. Okay, if you have a question about that, let me know. Okay, all right. Oh yeah, so here we go. I did it actually in the next slide. See, years, the yield, apple, and here we go. Here we got the graph, and we can see like, here there's draw the years. We got the growth of the yield of apples. So can you see the importance of visualization? Why visualization is important? Draw just a simple data. Now, of course, here it's not problem. This is like a small data set, but for large data sets, we're gonna use simply pandas. And that's why I told you in the classwork, we're going to have exercise like combination between pandas and plot. Okay, working with that would be more convenient. All right. Now, of course, sometimes, or let me say most of the time, as a data scientist, you need to make sure to compare your data. Or let's say that we got a farm that products, let's say oranges and apples, and you need to make sure which one has more productions or how, how the growth of production between apple and apples and oranges vary. Okay, so it's simple. Just make sure to have the years, like should be the same years, and then the data of apples, the data of oranges, and then you have to make a plot for years and apples, plot for years and oranges. It's gonna make them it's gonna be for both on the same graph, and you can make the comparison and draw the graph. You can see that the yield of oranges the growth is going down. However, the growth of apples is going up. Okay, but there is a problem right here. Okay, you can see the graph, but you cannot know which one is apple and which one is oranges. Imagine you are working on project and making presentation of your work. Okay, and you have to make sure at that time, let's say that you forget what's going on, which one is apple, which one's in oranges, and imagine also you got three products, for example, and you want to make the comparison. So what we're gonna do is simply add something called legend. Okay, it's important. Anytime you make graph, whatever is the graph, okay, correlation, I don't know, we're gonna see a lot, we're gonna see also maps, etc. But mapping is something different. But for here, you're gonna make sure, first step, make sure to label your x-axis, make sure to label your y-axis, make sure to put in a title of your graph. This is very, very important. Make sure, now either you got two graphs or you got one. Make sure, or let me say, the legend for one graph is not really important as long as you got title, but make sure to add something called legend. Okay, and legend should be in the same order of your graphs. So let's say that the first graph is going to be apple, then in the legend statement, it should be apples first. Okay, and vice versa. Okay, hopefully it's clear. All right. Okay, sometimes okay, especially for this case. But for large data, I would not recommend to do markers. But sometimes depends actually on the project that you are working on. It is important to put markers. So, like for example, each year we need to check out the value. Or let's say that we have a product in Amazon in a certain store, and we need to make sure monthly the sales, okay, through year. At the time, it is important to to know like how many sales do we have each month. Do we have a growth, or actually our sales is going down? What's going on? Okay, at that times markers is important. It might be circle, cross, square, diamond, doesn't matter. Most important, you know what does it mean. And just like I said, because we are doing sorry comparison, the legend is important, the title is important. I'm saying that because most of the students they forgot to label the x-axis, the y-axis. Of course we're going to have some projects, and then I'm gonna focus on what you do on your graphs. All right, okay. Now, as you can see, well, one of the things that I really like, and let me say, um, I'm gonna make your chart look beautiful and look good, is to add a grid. And on the background is going to be grid. Okay, to do that, you just have to use a function in the Seaborn library, which is sns.setStyle white grid. Now, as the graph here is white grid, but of course, if you want to make a dark grid, it's gonna be not dark, but kind of gray, and it looks good too. And you can see the difference between the previous visualization and the current visualization. We do have kind of beautiful looking. Okay. All right. Okay. Now, we're gonna move on to bar graph. Okay, let me tell you that bar graph is most likely used in categorical data, because in categorical data our x-axis is not going to be numbers, but it's going to be labels within chart type, or letters, or it's not going to be numbers. Or let's say that we are working on like in a company, we need to know how many women do we have, and how many females, and how many males. And at that time, actually this is a categorical variable, okay, because it's not numerical. And most likely is bar graph, but it is also used if for numerical values. Most likely if we are having like years, yes, we can do that. And let me say, for example, I want to check in 2000 for the apples, the proportion or the percentage, and 0.35 for 2000, 60% for 2001, etc., etc. Okay. Then the graph is just called, instead of plot, it would be bar. Okay, and then the years, it would label the years, and then the oranges. Here we got the graph of oranges, okay, because this is 40%, this is 80%, this is 90%, 70%, etc., and 80%, because this is not apples, okay. But of course you can do it for four apples, doesn't matter. That's number one. Number two, sometimes we want to do like a bar chart for both apples and oranges. Okay, how you gonna do that? So basically, no problem, you just have to make sure to show when you make the bar, you're gonna show which one is going to be bottom. So like for example, if you want the bottom is going to be apples, the value, then the blue part is going to be apples, and the top one is going to be within different percentage. Hopefully it's clear. So like for example, if I go to the top, let me make sure that you understand. Now here it's 40% and here is 35%, okay? Or 0.4 and 0.35. All right. This is means that the blue part is going to be 0.35 and the top one is going to be 40%. Okay. That's why 30 plus, 35 plus 40 is 75. So it makes sense. Same thing for 2001, etc., etc. Okay. Okay, for in this part we will use a Seaborn library and we will use the TIPS data set. The data set consists of um, information about the sex, times of the day, the total bill, tips given by customers visiting the restaurant for a week, and we can draw a bar chart to visualize how the average bill amount varies across different days of the week. Okay, now basically for these data set tips, um, there is a data set called tips already in Seaborn, so you don't have to include it. It's there, okay, and it has these variables information like per day, how many women and how many men are in, time of the day, the total bill, like how much they spend there, the tips given by the customer visiting the restaurant, etc., etc. Okay. Now let's say that you want to make the bar plot on Seaborn, not Matplotlib. Yes, you can do that. You just have to specify. That's why Seaborn is good, okay? Because it's easier in statistical analysis. So X is the day, Y is the total bill, and data is just make sure because our data is loaded as tips dash df, so you just have to specify your data, what's going to be your x value and what's going to be your y value. And you can do it also, you can do that also within a data set, draw pandas. It's no problem. We're gonna do an example in the classwork like that because this is very, very important. I would prefer or I would recommend to use bar plot within Seaborn rather because easier, it's easier, especially when we got if we got like a small data set, no worries. But for large data set, I would recommend this one. Okay, please remember, if you remember the matplotlib, it's just bar, okay? I insist on that because you might have question about this. And however, the bar plot in Seabird, it's bar plot, okay? And within the extension of the module that we have used, okay? Oh, sorry. And okay, let me go a little bit. Okay, I skip steps. Yeah, so because we got the days, it's gonna show up the days, it's gonna show up you know for each day the total bill. Okay, now well, hopefully I didn't skip let me go back. Yeah, I'm fine. I didn't skip the slide. That's important. Okay. Now, okay, if you want to compare bar plots side by side, or let's say that you want to see draw each day the male customers and the female customers within how much money they spend, and this is very very important, okay, for products, either in a restaurant, either in Amazon stores, either in any online shopping, any actually store. It's important. This information is important in your exploratory EDA, okay, data. All right. So it's easy. Just gonna specify you and add what the hue argument, okay, before the data, and it's gonna show up, it's gonna work, okay. Just like I said, my recommendation, make sure to run each code. It's really important. Okay, after that, just like I said, this data set is already in the Seaborn, so you don't have to include it or something. But if you want it, I have it, okay? I have the data set. It's also in Kaggle. If you make a search, you would find it in Kaggle. However, if you don't want to waste time, I'm gonna let you know where to find it. Okay? Now, histograms. Let me say that actually histograms are working in numerical data. A histogram is a bar representation of the data that varies over a range, okay, over values. It plots the height of the data belonging to a range along the y-axis and the range along the x-axis. Histograms are used to plot data over a range of values, and they use a bar representation to show the data belonging to each range. Okay? Now, let's walk through the IRIS dataset, the flower. As you remember, this dataset has 150 rows, right? 100 to 149, and we do have features: the sepal length, the sepal width, the petal length, the petal width, and then the species. And as you know, we do have 3 species, if I remember actually, and because let's say if you want to check out the distribution of the sepal length, for example, okay, or I think I did it for the sepal width, whatever, okay, just pick one of them. Remember that it should be histograms work most likely with you know so like I said, it should work with the numerical variable, okay, numerical feature. What I want to say is not numerical variable. What you have to do, just like PLT, and just you're gonna specify what feature. When here it's the sepal width, that's why I told you you're gonna make sure it's the sepal width. You also, in the histogram, it is important to specify the number of beans. So if you want 5 beans, then you're gonna say the beans equals 5. You can also change the the range, the minimum value and the maximum value, and you know okay. All right. Um, so similar to line chart, we can draw multiple histograms in a signal chart, and you just have to specify, for example, if you want to do the sepal length for each species, then it would be like the flower data frame, that species, and then you have to specify which one. Okay, and then you have to recall for each data set the sepal weight, and then it's gonna be drawn. Okay, just like I said, even if I told you here, you have to make sure to um, type this on your Python. Okay, it is very very important. Okay, all right. Well, hopefully you can see that, but if you cannot see it, I'm just gonna zoom in. Multiple histograms can be stacked on the top of one by setting the stacked parameter to be true. So, like for example, if you want to make sure to check if this is what type of species, just make sure to do stacked equals true. Okay. All right. Okay. This is not going to be the last one, but let's say that you wanna check if there is any pattern or relationship between one of the features. Let me say the sepal length and the sepal width. I want to check, okay, the relationship. Now the best way to do that is to draw a scatter plot. And what does mean a scatter plot? A scatter plot is simply you like hold on. You're gonna make a dot. Now x, for example, is going to be the data frame dot sepal length, and then the data frame dot sepal width, and then draw the dots everywhere, x value, y value, and check if there is any patterns. Okay. Um, we can do that for all species, okay? And we just have to add the parameter here in the scatter plot. And make sure to do the scatter plot though, draw Seaborn, okay? Instead of Matplotlib, because like I said, Seaborn allows us to like to have these parameters, okay? However, Matplotlib is not, it, it can be, but it's more complicated, okay? Remember that. Or lastly, that's going to be the last part of the heat maps. If you remember, we already did the heat map, but let's say heat maps are used to see changes in behavior or gradual changes in data. It uses different colors to represent different values based on how these colors in hues intensity tells us the phenomenon varies. Let's use the heat map to visualize monthly passenger footfall in an airport over 12 years. Okay, now this data set called passenger, okay, it's in it is in the SNS, okay, the Seaborn library. If you cannot find it, then you have to let me know. The data set is called flights, okay, and if you wanna see that, draw the heat map, you're just gonna do Seaborn that heat map. It's gonna show you the different intensity, draw the month of the year. So like for example December in 1949, December in 1915, December in 1950. You can check the differences, okay? Do we have more passenger in this? Do we have less passenger? And same thing for the other months, okay? No, but basically heat map is most likely used when we do have when we need to check correlations, and we need, is there any correlation between features? But it's fine. We right now we're gonna use it for that example, and later we're gonna check it for other examples. Okay. Now, lastly, I would just say thank you for watching the lecture. I would recommend to let me know your question if you do have any. Lastly, make sure to draw each comment in our lecture. And thank you, and see you in the next one.